The new electrical code requirement focuses on disconnects for fluorescent fixtures and its impact on commercial wiring. The code mandates electricians to install a disconnect for each fluorescent fixture. This is expected to increase both the cost and the time required for installation. However, this change is primarily aimed at enhancing safety. The primary reason for this new requirement is to address the issue of fluorescent fixtures continuing to operate even after the main power supply has been switched off. This poses a significant electrical hazard, potentially leading to fires. The disconnect will enable electricians to completely isolate the fixture from the power source, ensuring safety during maintenance or repairs. It's important to note an exception to this new rule. Multi-wire circuits that have at least 2 switches in each room are exempt from this requirement. The exception does not apply to rooms that are 5 square feet or less. This exemption exists because multi-wire circuits are already designed in a way that provides a disconnect for each individual fixture connected to them. The addition of disconnects will come at an increased expense and require more time for installation. The improved safety is worthwhile. There are several key aspects of the National Electrical Code, or NEC, to keep in mind when discussing electrical installations. Firstly, understanding the scope of the NEC is crucial. The NEC covers a wide range of electrical installations, including residential, commercial, and industrial settings. It provides comprehensive guidelines for safe electrical practices. Secondly, the NEC is updated every 3 years to reflect advancements in technology and address emerging safety concerns. Staying current with the latest edition of the NEC is essential for electrical professionals. Thirdly, the NEC is not a design manual, but rather a set of minimum safety standards. While it provides guidance on how to install electrical systems safely, it does not dictate specific design choices. Fourthly, the NEC is adopted and enforced by local jurisdictions, such as cities, counties, and states. These jurisdictions may have amendments or additions to the NEC based on local needs and regulations. Fifthly, the NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical installations. Understanding the structure of the NEC is essential for navigating its provisions effectively. Chapter 1 of the NEC covers general requirements that apply to all electrical installations. This includes definitions, wiring methods, and overcurrent protection. Chapter 2 of the NEC focuses on wiring and protection. This includes requirements for conductor sizing, insulation, and grounding. Chapter 3 of the NEC addresses wiring methods and materials. This includes requirements for conduit, cable, and raceways. Chapter 4 of the NEC covers equipment for general use. This includes requirements for switches, receptacles, and lighting fixtures. Chapter 5 of the NEC focuses on special occupancies. This includes requirements for hazardous locations, healthcare facilities, and swimming pools. Chapter 6 of the NEC addresses special equipment. This includes requirements for electric signs, elevators, and welders. Chapter 7 of the NEC covers special conditions. This includes requirements for emergency systems, fire alarm systems, and communications systems. Chapter 8 of the NEC focuses on communications systems. This includes requirements for telephone, data, and cable television systems. Chapter 9 of the NEC contains tables and examples. These provide additional guidance for applying the NEC provisions. Understanding the NEC definitions is essential for interpreting and applying the code correctly. The NEC provides definitions for a wide range of terms related to electrical installations. Some key definitions include ampacity, the current carrying capacity of a conductor. Branch circuit, a circuit that extends from the last overcurrent protective device to the outlets. Conductor, a material that allows electricity to flow easily. Grounding, connecting electrical equipment to the earth to provide a low impedance path for fault current. Overcurrent protection, devices such as circuit breakers and fuses that protect against excessive current flow. Raceway, a channel designed to hold wires or cables. Voltage, the electrical potential difference between 2 points. Understanding wiring methods is essential for safe and reliable electrical installations. The NEC specifies various wiring methods for different applications. Some common wiring methods include rigid metal conduit, or RMC, a heavy-walled conduit used for protection against physical damage. Intermediate metal conduit, or IMC, a lighter walled conduit similar to RMC. Electrical metallic tubing, or IM, a thin-walled conduit commonly used for indoor applications. Flexible metal conduit, or FMC, a flexible conduit used for connecting equipment that may move or vibrate. Non-metallic sheathed cable, or NM cable, commonly known as Romex, used for residential wiring. Understanding overcurrent protection is crucial for preventing electrical fires and equipment damage. The NEC requires overcurrent protection devices to be installed in all circuits. Circuit breakers and fuses are the two most common types of overcurrent protection devices. Circuit breakers can be reset after they trip, while fuses must be replaced. The size of the overcurrent protection device must be matched to the ampacity of the conductors it protects. Grounding is essential for electrical safety. The NEC requires all electrical equipment to be grounded. Grounding provides a low impedance path for fault current, which helps to prevent electrical shock. Grounding also helps to stabilize voltage and reduce electrical noise. Understanding voltage drop is important for ensuring proper equipment operation. Voltage drop occurs when voltage decreases along the length of a conductor due to resistance. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC provides guidelines for calculating voltage drop and selecting conductors that minimize voltage drop. Understanding bonding is essential for creating a safe electrical system. Bonding is the process of connecting metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to prevent electrical shock and reduce the risk of fire. The NEC specifies bonding requirements for various types of equipment and systems. These are important and are in the NEC Section 250. The National Electrical Code, specifically Section 410.73, subsection G, addresses the requirements for disconnects in fluorescent fixtures. This section mandates that each fluorescent fixture must have a disconnecting means that meets specific criteria. The purpose of this requirement is to ensure that electrical workers can safely de-energize the fixture before performing any maintenance or repair work. The disconnect must be readily accessible to qualified personnel, meaning it should be located in a place where it can be easily reached without having to remove any permanent parts of the building structure or finish. The disconnect must also be capable of being locked in the open position. This lockable feature prevents the circuit from being accidentally energized while someone is working on the fixture. The disconnect must be a switch or circuit breaker that is rated for the voltage and current of the circuit. It is not permissible to use a pull chain or other type of non-rated disconnect. The disconnect must be located within sight of the fluorescent fixture, or be capable of being locked in the open position. This ensures that the person working on the fixture has control over the circuit and can verify that it is de-energized. In situations where the disconnect is not within sight of the fixture, it must be lockable to prevent accidental re-energization. There are a few exceptions to the disconnect requirement for fluorescent fixtures. The first exception applies to fluorescent fixtures that are connected to multi-wire branch circuits. Multi-wire branch circuits are those that share a common neutral conductor. If each fixture on the multi-wire branch circuit has its own individual switch, then a disconnect is not required for each fixture. The second exception applies to fluorescent fixtures that are part of a listed lighting assembly. A listed lighting assembly is one that has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or AL. If the lighting assembly has its own internal disconnect, then a separate disconnect is not required for the fixture. When installing disconnects for fluorescent fixtures, it is important to follow the manufacturer's instructions and all applicable electrical codes. The disconnect must be properly sized for the voltage and current of the circuit. The disconnect must also be installed in a location where it is protected from physical damage. The disconnect should be clearly labeled to indicate which fixture it controls. Disconnects for fluorescent fixtures are an important safety feature that helps to protect electrical workers from electrical shock and arc flash hazards. By following the requirements of the National Electrical Code, electrical contractors can ensure that fluorescent fixtures are installed safely and in compliance with all applicable regulations. The requirement for disconnects in fluorescent fixtures is an essential safety measure designed to protect electrical workers. While it may add some cost and complexity to the installation process, the increased safety it provides is well worth the investment. Section 410.73 addresses specific requirements for fluorescent luminaires, covering various aspects of their installation and operation. Subsection G, which mandates disconnects, is only one part of this broader section. It is important to consider the other subsections to have a complete understanding of the code requirements. For example, other subsections of 410.73 cover topics such as the support of luminaires, the wiring of ballasts, and the grounding of luminaires. All of these requirements work together to ensure the safe and reliable operation of fluorescent lighting systems. The disconnect requirement in 410.73G has significant implications for the design and installation of commercial lighting systems. Electrical designers must now consider the placement of disconnects when laying out lighting circuits. Electricians must factor in the time and cost of installing disconnects when bidding on jobs. Building owners and managers must be aware of the disconnect requirement to ensure that their lighting systems are in compliance with the code. The disconnect requirement in 410.73G is intended to address the specific hazards associated with fluorescent lighting systems. Fluorescent lamps operate at high voltages and can store a significant amount of energy even after the power is turned off. This stored energy can pose a shock hazard to electrical workers. The disconnect provides a positive means of isolating the fixture from the power source, ensuring that it is safe to work on. In addition to shock hazards, fluorescent lighting systems can also pose a fire hazard. Ballasts, which are used to regulate the current to the lamps, can overheat and fail, potentially causing a fire. The disconnect allows electrical workers to quickly de-energize the fixture in the event of a ballast failure, reducing the risk of fire. The disconnect requirement in 410.73G is just one example of how the National Electrical Code is constantly evolving to improve electrical safety. As new technologies emerge and new hazards are identified, the NEC is updated to reflect the latest knowledge and best practices. Staying current with the NEC is essential for all electrical professionals. The NEC is not intended to be a rigid set of rules that must be followed blindly. Rather, it is intended to be a flexible guide that can be adapted to suit the specific circumstances of each installation. The electrical inspectors have the authority to interpret the NEC and make judgments about whether an installation is in compliance with the code. It is important to work closely with electrical inspectors to ensure that all installations meet the requirements of the NEC. The National Electrical Code is an essential resource for ensuring electrical safety. By following the requirements of the NEC, electrical contractors can help to protect workers, prevent fires, and ensure the reliable operation of electrical systems. One of the most important aspects of the NEC is its focus on grounding and bonding. Grounding is the process of connecting electrical equipment to the earth, providing a low impedance path for fault current. Bonding is the process of connecting metal parts of an electrical system together, creating a low impedance path for fault current. Grounding and bonding help to prevent electrical shock and reduce the risk of fire. The NEC specifies detailed requirements for grounding and bonding in various types of electrical systems. These requirements are based on the principles of electrical safety and are designed to minimize the risk of electrical hazards. Another important aspect of the NEC is its focus on overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. Overcurrent can be caused by short circuits, overloads, or ground faults. If the current in a circuit exceeds the rating of the overcurrent protection device, the device will trip, interrupting the flow of current and preventing damage to the circuit. The NEC specifies the types and sizes of overcurrent protection devices that must be used in various types of electrical circuits. These requirements are based on the ampacity of the conductors in the circuit and the type of equipment that is being protected. The NEC also addresses the issue of arc flash hazards. An arc flash is a dangerous electrical explosion that can occur when there is a short circuit in an electrical system. Arc flashes can cause serious burns, blindness, and even death. The NEC requires electrical contractors to take steps to protect workers from arc flash hazards. These steps may include using arc-rated clothing and equipment, and implementing safe work practices. The National Fire Protection Association, or NFPA, also publishes a standard called NFPA 70E, which provides guidance on how to protect workers from arc flash hazards. The NEC is not a static document. It is constantly being updated to reflect new technologies and best practices. The NEC is revised every 3 years by a committee of experts from various fields, including electrical contractors, engineers, inspectors, and manufacturers. The revision process is open to the public, and anyone can submit proposals for changes to the NEC. Staying current with the latest edition of the NEC is essential for all electrical professionals. The NEC is a complex document, and it can be difficult to understand all of its requirements. Electrical contractors should seek out training and education opportunities to improve their understanding of the NEC. There are many organizations that offer training courses on the NEC, including the International Association of Electrical Inspectors, or IAE, and the National Electrical Contractors Association, or NECA. The NEC is an essential resource for ensuring electrical safety. By following the requirements of the NEC, electrical contractors can help to protect workers, prevent fires, and ensure the reliable operation of electrical systems. It is important to remember that the NEC is a minimum standard. Electrical contractors should always strive to exceed the requirements of the NEC whenever possible. By going above and beyond the NEC, electrical contractors can provide their customers with the safest and most reliable electrical systems possible. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These may include local building codes, state electrical codes, and industry standards. Electrical contractors should be familiar with all of the codes and standards that apply to their work. The NEC is not a substitute for good engineering judgment. Electrical contractors should always use their knowledge and experience to make sound decisions about electrical installations. If there is any doubt about the proper way to install an electrical system, electrical contractors should consult with a qualified electrical engineer. The NEC is a valuable tool for ensuring electrical safety. By using the NEC in conjunction with good engineering judgment, electrical contractors can provide their customers with safe and reliable electrical systems. Understanding the practical implications of code requirements like 410.73. She requires a deeper dive into real-world scenarios. Consider a large retail space with hundreds of fluorescent fixtures. Before this code update, the installation might have involved basic wiring to each fixture, with circuit breakers at the panel serving as the primary disconnect means. Now, each fixture must have its own readily accessible disconnect. This means more components, more wiring, and more labor. Electricians must carefully plan the placement of these disconnects to ensure they are accessible for maintenance but also aesthetically integrated into the space. In an office building, the impact is similar. While the aesthetic considerations might be different, the core requirement remains the same: each fluorescent fixture needs a disconnect. This can lead to discussions with architects and building owners about the best way to incorporate these disconnects without disrupting the overall design of the space. The multi-wire branch circuit exception is crucial. In existing buildings, rewiring to take advantage of this exception might be cost-effective. By reconfiguring the circuits to include multiple switches per room and utilizing multi-wire configurations, the need for individual fixture disconnects can be avoided. However, careful analysis is needed to ensure the existing wiring can handle the load and that the new configuration meets all other code requirements. The selection of disconnects is also important. While a simple switch might suffice, many electricians opt for small, enclosed circuit breakers as disconnects. These offer an added layer of protection and can be easily identified and operated. The disconnects must be appropriately rated for the voltage and current of the circuit. and they must be installed in accordance with the manufacturer's instructions. Labeling is another critical aspect. Each disconnect must be clearly labeled to indicate which fixture it controls. This helps prevent confusion and ensures that the correct fixture is energized during maintenance. Clear and durable labeling is essential for long-term safety and compliance. The impact on maintenance is significant. With individual disconnects, maintenance personnel can safely work on a single fixture without affecting the entire circuit. This reduces downtime and improves safety. However, it also requires maintenance personnel to be familiar with the location and operation of the disconnects. Regular inspections and testing of the disconnects are also necessary to ensure they are functioning properly. From a cost perspective, the new code requirement adds both material and labor costs to electrical installations. The cost of the disconnects themselves can be significant, especially in large installations. The labor costs associated with installing and wiring the disconnects can also be substantial. However, the increased safety and reduced downtime can offset these costs in the long run. The disconnect requirement also has implications for energy efficiency. By allowing for individual fixture control, it becomes easier to implement lighting control strategies such as dimming and occupancy sensing. These strategies can significantly reduce energy consumption and lower operating costs. However, the disconnects must be compatible with these control systems to ensure proper operation. There are different types of disconnects that can be used, each with its own advantages and disadvantages. Toggle switches are a simple and cost-effective option, but they may not be suitable for all applications. Circuit breakers offer added protection, but they are more expensive. Fuse disconnects provide both overcurrent protection and a disconnect function, but they require periodic fuse replacement. The choice of disconnect depends on the specific requirements of the installation. The disconnects must be installed in a location that is protected from physical damage. This may require the use of enclosures or other protective measures. The disconnects must also be accessible for maintenance and repair. They should not be installed in locations that are difficult to reach or that are obstructed by other equipment. The NEC requires that all electrical work be performed by qualified personnel. This includes the installation of disconnects for fluorescent fixtures. Electrical contractors must ensure that their employees are properly trained and licensed to perform electrical work. They must also provide their employees with the necessary tools and equipment to perform the work safely. The enforcement of the NEC is the responsibility of local electrical inspectors. Electrical inspectors review electrical plans and inspect electrical installations to ensure that they comply with the NEC. They have the authority to issue citations and require corrections for any violations of the NEC. Electrical contractors should work closely with electrical inspectors to ensure that their installations are in compliance with the NEC. The NEC is a constantly evolving document. It is updated every 3 years to reflect new technologies and best practices. Electrical contractors should stay up to date on the latest changes to the NEC to ensure that their installations are in compliance with the code. The NEC is an essential resource for ensuring electrical safety. By following the requirements of the NEC, electrical contractors can help to protect workers, prevent fires, and ensure the reliable operation of electrical systems. It is important to remember that the NEC is a minimum standard. Electrical contractors should always strive to exceed the requirements of the NEC whenever possible. By going above and beyond the NEC, electrical contractors can provide their customers with the safest and most reliable electrical systems possible. The requirement for disconnects on fluorescent fixtures significantly alters commercial wiring practices. It necessitates a shift in design and installation approaches, emphasizing enhanced safety and control at the fixture level. Electricians, designers, and building owners alike must adapt to these changes to ensure compliance and maximize the benefits of the new code.